All right, so in this video, we want to sketch these polynomial functions with these conditions, basically. So the first question here, we have a degree of 4, we have a positive leading coefficient, 3 zeros, and 3 turning points. So let's start our sketch. We know that if the function is a degree 4 and a positive leading coefficient, both ends have to go towards positive infinity. So let's start the graph on the left over here. I want 3 zeros and 3 turning points. So let's start by taking this through over here because I know that's going to give me 2 zeros. And now I have 2 zeros and 1 turning point. I want to have a second turning point, so I'm going to turn over here. So now I have 2 zeros and 2 turning points. And now I want one more zero and one more turning point, which means that my final turning point has to be my 0 as well. And this is because if I go below the axis, I'll have too many zeros. I'll have 4 zeros, my third turning point. So my third turning point has to take place on my axis. And now I'll just go towards the top, towards infinity. So this satisfies a fourth degree equation with a positive leading coefficient and these two conditions. Let's take a look at the second condition. Again, it's a fourth degree, but it's a negative leading coefficient, which means that both ends have to be going towards negative infinity on the bottom. I only want 2 zeros and 1 turning point. This is pretty simple. This is just like a negative quadratic equation. It's just going to look like that. Because this is also a degree 4 function. It's degree 2, but it's also degree 4. It has a negative leading coefficient. It's going towards negative infinity on both sides. 2 zeros, 1 turning point. Let's take a look at the third one. Again, fourth degree positive leading coefficient, which means that my two end behaviors have to be going towards positive infinity. I only want 1 0 and 3 turning points. So 1 0 means I hit the axis and I have to turn back right here on the axis, otherwise I'll have 2 zeros. Once I turn back here, that's my first turning point. I need a second turning point and I need a third turning point. So I'm just gonna turn back over here before I hit the axis again. So I have 1, 2, 3 turning points, 1, 0, fourth degree, and it's a positive leading coefficient. Fourth question here, it's third degree negative leading coefficient. So from third degree and negative leading coefficient, it means that I'm going towards positive infinity on the negative side. So I'm going up here. And on the positive side, I'm going towards negative infinity. So I'm going down over here. So I know my graph has to start up here. I want just 1, 0. I want no turning points. So this is just a regular cubic function like this. No turning points at all. It's degree 3 negative leading coefficient, and we have 1, 0. All right, fifth question over here. It's a third degree function, positive leading coefficient. This means it has to go down towards this way here on this side and up towards infinity on this side over here. I wanted to have a positive leading coefficient, 2 zeros. So if I go like that and like that and like that, I'll actually have 3 zeros. I'll have 2 turning points and 3 zeros. So let's start on the bottom here. Let's go through the axis because we're allowed more than 1, 0. When I turn back here, I'm not going to come back through the axis. I'm just going to touch the axis. I'm going to go back up, and this is going to satisfy all the conditions because I have 2 zeros, 2 turning points, and it's third degree with a positive leading coefficient. All right, last one here, it's worded slightly differently. A fourth degree function, so it's going to be going up in both sides. Got 3 turning points, 2 zeros, and the range is y is less than or equal to 5. So this means that 5 is going to be my maximum. It's a degree 4 function. It actually doesn't tell us whether it's positive or negative coefficient, but because it's less than equals, it's actually going to be a negative coefficient because 5 is going to be my maximum. So I'm going to start on the bottom over here. I want 2 zeros, so that's my first 0 right there, and I need 3 turning points. So that's 1 turning point, 2 turning points. I won't touch the axis. Then I'll go up to 5 because that's going to be my maximum value. Y has to be less than or equal to 5. Then I'll come back down, and here it is my second 0. So I have 1, 2 zeros, 1, 2, 3 turning points, and my range is less than equal to 5, and it's a 4th degree function, so it satisfies all the conditions.